Hey guys, if you missed live class today, then this video is for you. This is our last class of the week because it's Thursday and there's no school on Friday. But everything you're doing now, we're going to be building on and on and on. So I want you to take a second to look at this map. Look carefully. This is a map of the world. You might not realize it because of the colors, but look and find. Here's North America and South America and Africa and Europe over here. What do you observe? What do you infer? Pause the video, answer the questions, and we'll keep going from there. I hope that you are observing this as a map of the US, that there are different plates named here. We're talking about tectonic plates today. Look at these red arrows too. They're moving. These plates are moving. We remember this from before. When they're moving in very different directions. And so sometimes you have two arrows pointing towards each other. Sometimes two arrows are kind of pointing around each other, kind of moving in opposite directions. Sometimes they're moving in direct opposite and moving away from each other. And we talk about how those three different movements, different interactions, change things about the plate. So we're going to be talking about that today. On this screen, I wanted you to look for us. We are just south of Seattle, kind of right down here where my pointer is. I guess let me turn on the, here we go. We live just down here. And we have a Juan de Fuca plate. We have our own tectonic plate. That's kind of just like southern British Columbia, Washington, Oregon, Northern California. It's called the Juan de Fuca plate. And it's right here. And it is responsible for a lot of our local geography and geology, which is really interesting. And we'll talk more about that as we go. But I wanted to point that out, that we have kind of a unique situation where we get to learn a lot about, like, why do we have the mountains and the volcanoes and the earthquakes and all that we have, and it has a lot to do with our own plate. So today, after our learning target and science of the day, some quick vocabulary. In breakout rooms, you're going to be doing some practice by identifying the three types of plate boundaries, and I pretty much just told you about them, about the different way that the plates are moving. There's a little game you get to play later, and an exit ticket quiz. Make sure you take that and you do well on it so I can put that in the grade book for you. Our science of the day is Dr. Zelma Main Jackson. She's an American geologist. She got her master's degree in economic geology from the University of Washington. She's African American. She's also a member of the Gulagichi tribal nation. So she also identifies as Native American. And she was she's nearing the age of retirement now, and so she has been working in geology and also for the Washington Department of Ecology for a really long time. She had to deal with a lot of racism early in her career, where she would go out and talk to these guys who were like living out, working on oil rigs for months at a time with just all white men, and then this small black woman would be coming in and telling them what to do, and they did not like that, and so she had to deal with a lot of that racism in her career, unfortunately. But she also was identified as someone who knew what they were doing, and she kind of rose through the ranks, and for the last 25 years, she's been working for the Department of Ecology and trying to monitor the groundwater out on Eastern Washington. So in our state, she's from Washington. In Eastern Washington, there's an old nuclear reactor in Hanford that helped to make some of the nuclear material that were used in the atomic bombs in the 1940s. But those have also been leaking and contaminating the groundwater. There's been a big ecological problems there. And so she works for the Department of Ecology, kind of leading the teams as they clean up the area and monitor the area fully. So thank you, Dr. Jackson, or Main Jackson, for all that you've done. We are going to be learning today, and I would like you to be able to describe the different interactions of tectonic plates. We're going to basically say that there are three different ones, okay? Remember that we are trying to explain how different geoscience processes change the Earth's surface. So today we're talking about tectonic plates. We got to make sure we understand what those are. They are these giant, irregularly shaped sections of the cracked outer crust of the Earth. I like this picture here because it kind of, oh yeah, the Earth is a ball. It's not flat like you see on all these maps. And the outer crust, think about this like the M&M, remember it's like that candy shell, is actually broken up into little pieces called plates. And they're moving, they're kind of floating on top of the mantle below, and the mantle is actually moving under them and dragging the plates around the earth. And because of that, a lot of things on earth are due to tectonic plates, and we'll talk a little bit about them today. So there are 7 major ones, you can kind of see them in here, and there's a lot of tinier ones. We're going to be talking a lot about our own plate, the Wanda Fuca plate, which is just right over here. It's a relatively small plate compared to the rest of the world, but it's important locally to us, and so we'll talk about it more. So we're talking today about plate boundaries, which are where 2 tectonic plates meet. It's the boundary between 2 plates. That makes sense. A lot of geologic activities like volcanoes, earthquakes, where mountains are formed, they take place at plate boundaries, and we're going to learn the 3 different types: convergent, divergent, and transform, and they have everything to do with just how they are moving relative to each other. So in breakout rooms, you're going to use this link up here to help you fill in this table. So there's 3 links. There's different places for you to click for each type. You're going to describe, is it the 2 plates are moving towards each other, away from each other, next to each other? Where is an example like that on Earth? And what can that cause? Read the whole thing, because one of them is the biggest cause of earthquakes. Some of them cause volcanoes. Some of them don't cause volcanoes, etc. So answer that. And then on the next slide, all I want you to do here is drag these GIFs. There's 3 GIFs here, and there's 3 pieces of map here. And I want you to identify which of these, like this one right here. This GIF, is it moving? It might have stopped. This looks like you can see the arrows, 2 tectonic plates moving towards each other. Is that a convergent, divergent, or transform plate boundary? And then once you figure that out, drag it to that here. So you're just doing a little card sort with 3 pieces of maps and 3 here. And if you're not sure about the maps, look at the arrows on the plate boundaries at the map. It'll help you know what type of boundary it is. And I just want to be clear about this. We are just off the map. We're like right here where my red dot is, maybe like that-ish. But remember, this is the plate of Wanda Fuca. So I just wanted you to look here real quick. What type of plate boundaries are near us? Do we have a convergent boundary near us? Do we have a divergent boundary near us? Do we have a transform boundary near us? Do we have all 3? Look at this map, think about that question. Your independent work then is just 2 things. There's a little game, and there's an exit ticket quiz. Oops, I clicked on the quiz, I didn't mean to. For the game, this is the link to it. First, watch the video, and then scroll down to the bottom to play the game. The video helps to kind of set the scene, and I wanted you to be clear about this, because they're calling the game is great, but I wish they used similar words to what we are talking about. You've heard us talk about subduction before, where one plate goes under another, and we'll talk about that again. But subduction is an example of a convergent plate boundary where 2 plates move towards each other. A collision is also a convergent plate boundary. That would be 2 continental plates colliding with each other. Spreading would be a divergent, moving across or away from each other. They just call it spreading here. And a slip is an example of a transform boundary where they are moving next to each other but in opposite directions, but not into each other or away from each other, but just slipping past each other here. And so using these words, go and play the game, and it's really good to see where the different boundaries are and what do they do to our Earth. So maybe some places on Earth that you've heard of exist because of these different plate boundaries. Finally, take this exit ticket quiz. If you open it up, I'm looking at it now. What type of plate boundary creates new crust? There's a little GIF. There's a thing on the map. There's a Wanda Fuca question looking at the arrows, etc. And then Himalaya range is formed by what? Fantastic. You guys totally got these 4 questions. Go and nail that, turn it in, and I'll see you not Friday, not Monday, but back to school on Tuesday. I'll